It is a review for exam 1. We'll go through all the exam problems, and some extra true or false problems will be considered for you to get more concrete concepts for what you have learned. Here, let's begin with number 1, which is a set of true or false problems. A basic variable in a linear system is a variable that corresponds to a pivot column in the coefficients matrix. It is true. In fact, this is a definition for basic variables. Whenever a system has free variables, the solution set contains many solutions. Is it true? Maybe not. To make the sentence true, we need one more condition. The system should have a solution and at least a free variable. Then the solution set contains many solutions, in fact, infinitely many solutions. So the current statement is false. If the coefficients matrix of a linear system has a pivot position in every row, then the system is consistent. It must be true. Here, the coefficients matrix has a pivot in every row. And then if we add one more column from right-hand side B, then this system must be solvable, must have a solution. So the system is consistent. The pivot position in a matrix depends on whether row interchanges are used in the reduction process. Is it true? The statement is false. Independently of row interchanges, the pivot positions will be decided when the reduction reaches to an echelon form, so that just independent of use row interchanges. Okay. A is given here, and is the system Ax equals B consistent for each B in R3? Okay, we'll try to answer the question and justify our answer. Okay. Here, to be consistent, each row should have a pivot position. So we may start with A and try to get an echelon form. Okay, now first row is not changing. Now by adding the first row to the second one, we have here 0 and 2, -1 and 4. Okay? And the last one is just 0, -4, 2, -8. Okay, the bottom row is -2 times the second row. So from here, 1, 3, 0, 3, and second row, and third row, by adding twice of the second row, we can make this a row 0. Okay, so we have a pivot here, but third row has no pivot, which means that for some choice of B, it has no solution. 0 cannot be non-zero. We can choose some B such that here 0 is non-zero. It's impossible, right? So in the case we don't have solution. So the answer is no, and this is the justification. Describe and compare the solution sets of A and B. Okay, this is non-homogeneous system, and this is corresponding homogeneous system. So let's try to find the solution of the non-homogeneous system. Then now if we ignore this -2, then it'll become the solution of this one. Okay, so let's focus on this one. Okay, let's try to get the corresponding augmented matrix. Okay, coefficients matrix 1, 5, -3, 0, 1, -1. Right side is -2 and 0. Okay, here from this one, now we have to reach at the reduced echelon form. So we have to eliminate this one, only the leading ones. So we have to eliminate that one by subtracting 5 times of the second row. Then it's 1, 0, okay, 5 times, subtraction of 5 times the second row, so it is 2, and here -2. Okay. And then this is 0, 1, -1, and 0. Right? Okay, 5 times subtraction, 5 times, okay, so it must be 2. Okay, here, x1, this is the leading one, and this is the leading one, 2 pivots, and so x1, x2 are basic variables, and x3 is a free variable. So when we try to solve the problem, we keep basic variable left hand side and everything else to the right side. This equation is the same as x1 plus 2x3 equals -2, so that from this first equation we have x1 equals same as -2 minus 2x3. Okay? And now the second equation is same as x1 minus x3 equals 0, so that there is x1, x2 equals x3. Now x3 is a free variable, so we put here x3 equal x3. Okay. From left hand side, we put here x to indicate these 3 components, and right side, okay, that is -2, 0, 0, and plus x3, and the direction is -2, 1, 1. This is a general solution of the non-homogeneous system, and for this one, once we ignore that portion, -2, so we eliminate this portion, then that will be the solution for the homogeneous system. Okay? So we can visualize here x1, x2, x3 coordinates. So that is x1, that is x2, and that is x3 direction. Then, okay, it's for that one, x1, that is a -2, so that is here, okay, over there, that is -2, passing this point, and direction is -2, 1, 1 direction, so that we may try to get that line. Okay, that's the solution for this non-homogeneous one, and for that one, just ignore this portion, then here passing the origin and -2, 1, 1 direction. The solution for homogeneous system, of course, they must be parallel, and this one is shifting from this one. Just in x direction, -2 is moved and then the parallel line, that all the points on the lines will be the solution. Okay. Okay, we have another set of true or false problems. V1, V2, V3 in R5, and these two are linearly independent, and V3 is not in span of V1, V2, then V1, V2, V3 is linearly independent. Okay, it is true. The reason is, once you start with V1 and V2, and two columns like that, V1 and V2, then these two are linearly independent, means that if you consider this as a matrix, then this matrix has two pivots. Here, one pivot and another pivot is here. Okay. Now, V3 is not in span V1, V2, which means that if you consider augmented matrix with V3, then it has no solution. That means now if you consider this one as a matrix, 3 columns, then it has another pivot here. That means 3 vectors are linearly independent. So it is true. Okay, these are in R3, and V3 is not a linear combination of V1 and V2. Then these are linearly independent. Is it true? Here, for example, you may start with, okay, and there is no other condition, so that not a linear combination of these two. Then you may simply choose one of them 0, for example. Then, now, this part will be true when you are choosing V3 independent from V2. So this portion will be true, but this is sad because V0 is 0, cannot be linearly independent. So it is false. And if you choose V1 equals 0, and so R3, so that practically you can choose in this way. Okay, V3 is basically E3, and now V2 is E2, and V1 is 0, then here there is E2. Then E3 is not a linear combination of 0 and E2. So this part is true, but satisfied, but this is not linearly independent, right? Okay, here 4 vectors in R4, and R4, V4 is V1 minus 2 V2, then this is linearly dependent. Yes, it's true. At least one of the vectors is a linear combination of others, then it must be linearly dependent. So it is true. V1 and V2 are in R4. V1 is not a scalar multiple of V2, then these two vectors are linearly independent. Is it true? Maybe not. Okay. Also, if you try to choose a simple one, for example, and V2 is 0, then it's a non-zero, then V1 cannot be a scalar multiple of 0 vector. But here, collection of these two vectors cannot be linearly independent. V2 is 0, then this set must be linearly dependent. So the given statement is wrong, false. A linear transformation T is determined by the following standard metric. And find all x such that here t of x is this side. Okay, let's say this is A and this is B. Then here the problem is asking you to find the solution of that system, AX equal B. How? Just start with augmented matrix and reach to the reduced echelon form and try to express the solution using a free variable. Then that's it. So you can finish this problem yourself. Try. Number 6. T is a linear transformation from R2 to R3 and given in this way. We need to check if it is 1-to-1. Okay, it is a 3 component. Right. Now here, if we try to use the standard matrix, then standard matrix will be decided action on the standard basis TE1 and TE2. Right? Okay. Here, E1 is x1 is 1, x2 is 0, so that when here we choose E1, then now this 2, minus 3, 2, minus 3, and 2. Right? Now for E2, here x2 will be 1, x1 is 0, so the first component is minus 1, second component is 1, and third component is minus 3. Okay. So more simply, you can collect the coefficients from this term, that term, that term, and put over there in the first row, second row, third row, 2, minus 1, minus 3, and 1, 2, and minus 3. That is the standard matrix. Okay. Now, here, for the matrix, standard matrix, if it has pivot position in each column, then it must be 1-to-1. But these two are linearly independent in different direction, so that if you work on this matrix with elementary row operations, then you can find 2 pivots, which means each column has a pivot, so that it must be 1-to-1. You can finish this one. Okay. Now we want to find x such that t of x equal 1 minus 2 minus 1. So if we define b, it's column vector, here 1 minus 2 minus 1, then this portion is asking you to solve a x equal b. Now again, start from the augmented matrix and apply elementary row operations to reach at the reduced echelon form and figure out. You can do it. Okay, now that's the end of the old exam problems. Now we'll go to extra true or false problems. Okay, yeah. And this is for you to get more concrete concepts for these new terms in linear algebra. Okay. Okay, here, let's begin with number 1. Every matrix is row equivalent to a unique matrix in echelon form is false. Reduced echelon form is unique, but the echelon form is not. So it is false. Okay. If a system of linear equations has 2 different solutions, it must have infinitely many solutions. Is it true? A must be true. Two different solutions means that there must be at least one free variable. So eventually, the number of solutions must be infinite. So it is true. Number three, if a system of linear equations has no free variables, then it is a unique solution. We solve this one when we are solving all the exam problems. It is one of them. So you need another condition. The system should have a solution and no free variable. Then the solution must be unique. So current one is false. If an augmented matrix AB is transformed into CND by elementary row operations, then the equations AX equals B and CX equals D have exactly the same solution sets. That must be true. Right? Elementary row operations will not change the solution. If a system AX equals B has more than one solution, then so does the system AX equals 0. Is it true? Is it true? It must be true. The more than one solution for the non-homogeneous system coming from, in fact, homogeneous portion. So that is exactly here. Once it is more than one, then it means infinitely many solutions. So homogeneous part is also infinitely many solutions. Okay, here, if an augmented matrix can be transformed by elementary row operations into reduced echelon form, then the equation is consistent. Is it true? It's false. The reason is here if statement is always possible. An augmented matrix can be transformed into reduced echelon form no matter what it is. So it is always true. So that if you claim this one, then here for some A and B, it may not be true. So the statement is false. The matrices A and B are row equivalent. They have the same reduced echelon form. It must be true. By using elementary row operations, you can transform A into B so that once they are reduced to reduced echelon form, then they must be the same. The equation AX equals 0 has the trivial solution if and only if there are no free variables. Is it true? No, it may not. This portion is always true, but it requires some conditions, and so that these two cannot be the same, so it is false. To make it true, you have to put here only. The equation homogeneous system has only the trivial solution, then if and only if there are no free variables. Okay. Number 9. A is an n by n matrix, and the equation AX equals B is consistent for every B, then A has m pivot columns. Is it true? Yeah, it must be true. here this system is consistent for every B, means that each row of A has a pivot position. There are M rows, so that there are M pivot positions, so that also, and here that pivot positions will make M pivot columns. Right? So it is true. If on n by n matrix, now it is a square matrix, has n pivot positions, which means that every row, every column has a pivot, then the reduced echelon form of A is the n by n identity matrix. It must be true, quite simply. If 3 by 3 matrices A and B each have 3 pivot positions, then A can be transformed into B by elementary row operations. Is it true? Yeah, it must be true. And B can be transformed into, by using this one, A can be transformed into identity, and also B can be transformed into identity. So that, like that here, A can be transformed to here into identity, and B can be transformed into identity. So that here, so that if you start from A and go here, and reverse operations will reach to B. So you can transform A into B. Right? Okay, number 12. If A and B are row equivalent matrices, and if the columns of A span Rm, then so do the columns of B. It must be true, right? So it's row equivalent, and the columns of A span Rm means that there are n pivot positions for A, and each row should have a pivot position. So that here, row equivalent means that also if they reach at here in echelon form, the pivot positions must be the same. So again, B should have M pivot positions. So it's true. 13. If none of the vectors in the set V1, V2, V3 in R3 is a multiple of one of the other vectors, then the set S is linearly independent. Is it true? It may be false. To make it true, rather than a multiple of one of instead of that one, and it's a linear combination of other vectors, then it'll be true. Okay. Number 14, these three vectors as linearly independent, then here U, V, W are not in R3. Is it true? Must be true. And here, if they are in R2, then its a number of vectors is larger than the dimension, so that they cannot be linearly independent. So here, this given statement is true. U, V, W are non-zero vectors in R2, then W is a linear combination of U and V. Is it true? It can be true, however, not always. For example, okay, and the condition is these three vectors are non-zero, so that here u, okay, is non-zero. Now v, okay, let's say there's twice of u, then these two linear combination will be again a multiple of u, because v is simply twice of u. So that this portion will make only multiples of u. If we choose w independent from u, then here this statement will be false. So here, okay, more explicitly, w is e2, so there's 0 and 1, and that is now e1, there's twice of e1, so that here, now, if you consider e1 and twice of e1, then always linear combination will be, from here, you can get only a vector such that something and second component must be always 0, so that you cannot make this w. Okay. Suppose that these three vectors are in R5, v2 is not a multiple of v1, v3 is not a linear combination of v1 and v2, then it is linearly independent. Okay. The answer for this one is false. But in the reference book, the answer is yes, so that we'll deal with this one. Okay. Let's try to choose v1, v2, v3 linearly dependent. But these earlier statement conditions must be satisfied. Okay. Now these three vectors are R5. v2 is not a multiple of v1. Okay. Let's try to choose v1 equal 0. Then if it is non-zero, then it's true. And v3 is not a linear combination of v1 and v2. Okay, so that we can choose v3 independent from v2, then also this one will be true. So that, for example, here v1 is 0 and v2 is e3, and now and then v2 is simply e2 in R5, then here everything is satisfied. Okay, that e2 is not a multiple of 0. e3 is not a linear combination of, now that is 0 and e2. These two are true, but here, because v1 is chosen to be 0, so that this set cannot be linearly independent, so that given statement is false. It's not true. Okay. A linear transformation as a function, yeah, is correct. And we defined transformation as a special type of function. In fact, function defined on Rn, defined in Rn. Okay, here A is on m by m matrix with m pivot columns. Then the linear transformation is one-to-one mapping. Is it true? Okay, here m indicates the number of rows, n indicates the number of columns. M pivots means that each row has a pivot, but it doesn't mean that each column has a pivot, right? So n pivot means that each row has pivot, so that the linear transformation must be onto. However, if n is larger than m, then there must be at least one free variable, so that it cannot be one-to-one. So the last statement is false. Okay, this is end of the review. Thank you.